Good morning, good day, and good evening to all our attendees joining us for today's latest Data Science Central webinar. I'd like to start our event off today by thanking ThinkBig for sponsoring today's event. We appreciate their support of the Data Science Central community, and we are honored to have them sponsoring our webinar today. I'd also like to take this opportunity to mention and show our appreciation for some of our other recent sponsors, including Cisco, Hortonworks, Tableau, Teradata, Pivotal, and TIBCO, to name just a few. These past webinars are available on demand at datasciencecentral.com, and if you've not had the opportunity to view them, I would encourage you to take a look, as they do provide some very useful information. Pardon me for one moment. I have a problem with my slide progressing there. Sorry about that, folks. Today's webinar is entitled Data Lakes, Reservoirs, and Swamps, a Data Science and Engineering Perspective. Before we begin, I'd like to briefly review the format for today's webinar. Today's event will be approximately 1 hour long. We have two panelists that I'll introduce to all of you in just a few moments. We will have about 10 to 15 minutes for Q&A following the presentation, and this event is being taped and will be made available after the presentation. My name is Tim Madison. I'm one of the co-founders of Data Science Central, and I'll be your host for today's webinar. I'm very pleased to introduce today's speakers, Dan Mellinger and Rick Stellwagen of ThinkBig. Dan leads ThinkBig's data science practice and is obsessed with the organizational side of analytics. He is known for his ability to lead creative analytics solutions that bridge business and engineering teams, which is supported by his unique background blending corporate research, technology, and business intelligence. Rick is director for ThinkBig's Data Lake program. After years of building highly available relational database systems, he led an e-commerce startup, became an enterprise and solutions architect in professional services, and in the past 3 years before joining ThinkBig, he served as manager and solution architect for Teradata's Big Data Global Benchmark Center. Thanks for being with us this morning, fellas. Looking forward to your presentation. In the fast-paced, never-changing landscape of Hadoop-based data lakes, there tends to be varying definitions of what constitutes a data lake and how they should be used for business benefit, especially in leveraging data science. In today's webinar, ThinkBig will share their perspective on Hadoop data lakes from their many consulting engagements. Drawing from their experience across multiple industries, Dan and Rick will share stories of data lake challenges and successes. You will also learn what it takes to become a qualified data scientist. And so with that, Rick, I'm going to start we have a quick poll I'd like to ask the audience to participate in. So you'll notice in front of you have a couple of selections. Please mark the appropriate box that you think is most appropriate. What analytics tool do you mostly use to tackle your data science challenges? So go ahead and mark the R, MATLAB, SAS, or I use all of the above, depending on the program, or none. I'm just here to learn about data science and data engineering. So go ahead and hit the submit button, and I will proceed with the next slide. Okay, I'm going to move forward. And there you go. So Rick, with that, I'm going to turn this over to you, and you can begin as soon as you're ready to go.
Great. Good morning, everyone. We're so pleased to be able to share with you some of our experiences in building data lakes and doing data science on them. So we're going to go over the data lake, pretty much how to build one, and also the data science around it, and finish up with the Q&A. So we're going to give you that perspective. I think I've already said it once before. Let's talk about how data lakes and the variety of the different types of data are the key differentiating factor in building a data lake. We're going to talk a little bit about how to build a reservoir in an enterprise, and then Dan is going to finish up with how to use a data lake or a reservoir for data science. So first, who is ThinkBig? And ThinkBig is really the first and leading most professional services group exclusively focused on Hadoop. And very much agnostic and vendor neutral with respect to the distribution vendor, hardware selection, or deployment model. ThinkBig has a academy to scale the delivery and training, and we're able to extend and integrate open source into customers' analytic reference architectures. We have an onshore team-based delivery that helps to drive costs down, and we have taken a lot of our assets and procedures that we have built and productized those IP assets to accelerate time to market, and also lower your overall cost of implementation and not be so dependent on a customization of a project. So we're going to talk about the 3 V's. I know this is boring and old, and everybody's talked about it in the past. But I need to quickly revisit the 3 V's and talk about where the differences are with what we're doing today as compared to what we saw before. In the past, kind of slow. The volume has always been attacked. Teradata actually was probably one of the first ones to really solve this problem in an MPP kind of way 25 years ago. There's been many different MPP systems built ever since then for relational, Netezza, Vertica, and now today with Hadoop. It's also a massively parallel architecture with shared nothing. This is really key in order to enable scalability. We all know this. It's been kind of well proven. Velocity has also been really tackled in the past, especially when it comes from a OLTP transactional perspective, right? MySQL, SQL Server, DB2 and Oracle are all big OLTP, and they're able to handle very, very high volume transitions, but not necessarily from a write fast perspective, right? So usually the workload is broken up between writes and reads, and you'll end up breaking out an operational data store for highly intensive read purposes. So velocity has been attacked in lots of different ways over the years. But the big difference here is variety, and that's the big defining force in big data. So we'll talk a little bit about that. So variety is really key. So when we look at variety and how you use your data, well, let's talk about data wildness of your data. And it's kind of a sliding scale from sort of an in situ situation where we have wild, unstructured situation to a very curated, moderated, governed perspective where things are highly modeled, maybe even materialized. So it's kind of a big variety, and it's a big balance between these two different aspects. There's no free lunch when you have to figure out your schema on the fly. What's really nice about the Hadoop situation is that you're able to do that. You're able to model and make useful use of data before you go into heavy modeling, and that's very useful in being able to profile, understand which data aspects you want to do, or those kind of occasional ad hoc queries. But when you do that kind of late binding kind of thing, you suffer a little bit from a performance perspective. Binding on the fly is not always the preferable way if you want to have things that are very quick response time. So that kind of translates to the common thing, schema on read. Schema on read is where you keep the data as fairly unstructured, maybe flattened out, parsed a little bit, but not really changed in any model, any perspective. And then you apply the model on the read time, as opposed to schema on write, where everything is predefined, pre-modeled, and actually some things are materialized. So as you have to really take a look at this, is that since you're really taking a look at raw data and applying models on the fly, you really aren't as confident in your answer. It's less known what it is. You haven't really done a lot of analysis to be able to validate and confirm what you're getting out of it. Whereas on the other end of the more curated model aspects, you have much more confidence in your answers. Now, each situation is good depending on what you're trying to do and where you are in the life cycle of managing your data. So variety is so key because not everything can kind of look like a table. So if you try to shove an image into a blob or a JSON file into a CLOB, you can do it. You can do that in a relational table, but it's not efficiently processed, and it's really not well understood, and you're still going to have issues with being able to parse it out. A lot of data is pretty nice, but a lot of it's not normalized, and they have different serializations aspects of it. So variety is a really key aspect to this. So as we look at this, continue to move it along, we say, okay, the data is less parsed when it's an in situation, or when it's more curated, it's more parsed. So that's kind of alluded to earlier. how much parsing you do and how much flattening and how much modeling really has to do with the variety and how you process your data. And today, here's kind of a landscape of how this kind of looks in the world today. And what's really cool is, you're seeing all these different technologies, Big, Hive, where you kind of look at from the very raw perspective on the left, and you start moving closer to more curation, right? So MapReduce, Java programs, schema on read with Hive perhaps, or a Pig program, starting to get a little bit more. You may produce maybe a little bit of modeled, and start to move closer and closer in using other technologies. And we were seeing where you see things like Stinger from Hortonworks and Greenplum's Hawk situation, and Teradata's got a query grid capabilities as well, where you're starting to look at applying some relational model on top of the raw things. So ultimately, you get to, if you want, highly modeled, highly known situation where the data is curated. Usually that's in a SQL database, but it could be in a big data platform as well. So as I said before, there's no real free lunch when you try to do this late binding, right? So when you're looking at this raw late binding schema on read, you're going to be slower to get your answers, right? And as it's curated and modeled and pre-calculated, you're able to do a lot quicker response times. So there's always this big variety you have between the two choices. But what's kind of cool and what's really great about big data is that you're able to do that, and you have the flexibility to do it any way you want. So variety, again, it's the defining factor. So it's only one of the dimensions by which you choose to use a technology. So big data has so many different choices in order to analyze it, right? So maybe you want to have a much more memory-oriented, iterative approach with smaller data sets and using Spark. You could have data access patterns, which are kind of more pre-built with Cassandra or HBase. You got graph-oriented functionalities. You have indexing and search capabilities, streaming capabilities that really streaming has become a lot more prevalent, and there's many different streaming technologies now with big data. Sitting on whether you're like your ESB to be ActiveMQ or Kafka, it doesn't really matter. The streaming technology is really coming to the forefront. It's more available. So, but what we've really found is some experience with people is to try to push too much streaming technologies in places because it's new and it's greatest where it's not really necessary. So streaming is great. It gets you data more quick, so that it addresses the variety, the velocity perspective of things. So you're able to see it, but then it's very difficult to track the lineage of that data sets when you're starting to pull things in a much smaller batches. Okay, so let's kind of talk about what a data lake is. And I always like to say a data lake is sort of the jumping in aspect of things. So you you're jumping in. You built your Hadoop data lake, and now you're trying to push all the data in there. So we're going to say it's like a centralized repository where all the data comes in and which downstream facilities can draw from. So this is your drop zone. We have a lot of implementations where people are using HDFS as their drop zone now, or we're pushing it into a drop zone. So they're sourcing the data out of the data lake. But you really need to make sure that your data is solid before anybody can start provisioning it, right? So first we got to ask, how is this really different from a data warehouse? And so really, the centralized persistence of raw data from multiple sources, it can get transferred prior to entering the data lake, or it can come in a raw perspective. But really, if you want to have the additional guarantees around quality, provenance, and metadata and security, you need to have a data reservoir. That's what we want to call it. And importantly, it should really work with a computational engine. So instead of just having a big SAN, you have computational access as well. So that's a big key aspect to be able to have this data lake, is more than just a drop zone, is to be able to have that comp engine along with it. So we like to use lakes because it's a nice metaphor, right? It's easy to follow the data or not. So basically, we look at a lake or an ocean. Some people like to call it that, or a hub, and it's a perfect place for you to be able to do consolidation, to be able to co-locate all the data together, easy to flow data into and out of, just as you would with a lake or a reservoir or lake or streams downstream. But what if you throw a cup of water in a lake? Can you really find out where that is? This could be a really bad thing. Where's your cup of water? Now co-located amongst all the other pieces of water. So let's think about that a little bit more and some of the metaphors around it. A reservoir. So we'll kind of build on that, and the reservoir is always something we think of as protected, guaranteed, cleaned, and stewarded. So those are the kind of things we want to build on, those kind of metaphors. And, this is a lot of words to define what a reservoir is, but it really is a place where you add the business level guarantees. You want to be able to govern the data. You want to make sure you understand the permissions of the data as it comes in. You want to be able to track the lineage. You need to be able to go back and debug where anything might have gone wrong in your journey of non-curated to curated type of data, because there'll be a mixture of both of those in your data reservoir. But the really key important thing is the tracking of the metadata. The metadata is so critical. You need to be able to track more than just this normal schema type of metadata, and I want to talk a little bit about that. So a water treatment plant is kind of what we're going to build on. We want to go from, do we want to have a swamp or a reservoir? And we want to have a reservoir. A swamp is where the cup of water went in there. We have no idea where it went to. So metadata is the key aspect. Schema metadata is always a given. You have to have the very minimum so you know exactly how this data is going to map out. But really, what we want to talk about is way more types of metadata and how we would use it. So there's three types of our areas in this. We have a treatment, we want to call a treatment facility, a reservoir, and a lab. Looks like I somehow skipped some slides. So I'm going to go back a little bit. I don't know how it got advanced. Okay.
Rick, just go to the storyboard and you can click on the top and then launch that. Which slide do you want to go to?
Gone. They're all gone. Okay, so we'll just talk about it, and let me go back a minute and talk about all the different types of metadata for a second. There were some slides on metadata. I don't know why they went away. But in any case, let's just talk a little bit more about the metadata. And so what I was going to kind of go into is talk about not just the schema metadata, but also the aspects of the business metadata, which that's really permissions, access patterns, end target models. Operational metadata, really important. This is who touched the data and where, and exactly be able to track the lineage of it. So we really emphasize with Think Big being able to track the lineage of the data from start to the end, from wherever it's been sourced. And we actually go through a lot of efforts. And let me go through a use case and kind of draw that out a little bit. So apologize for that. So here's a kind of sample architecture. So you could consider this maybe a little bit controversial because what we're showing here is really three different Hadoop clusters that we're using in our reservoir. Now, everyone likes to think of it as a centralized single cluster. As long as it's centralized and coordinated and integrated, you can look at it as a single cluster where you manage the workload for all the different things that come in and how you would kind of transform and get data ready to be pushed out or even consumed in the lake, as Dan Mellinger will talk about. But each region might have a different area, and we'll talk about three different areas in this as well. So we talk about maybe a treatment facility where the data comes in and gets readied, and then you push it down to different types of other facilities downstream. So here's the treatment facility. You know, it's really used by IT, by operations only. It's restricted. There's an ingest zone. You have it could be where we get to the data to a point where it's the system of record, right? This is where we try to maintain the raw data or the system of record data and make sure that it's something that it's reproducible, archivable, and encrypted. It'll be the lowest common denominator. It'll be the least modeled, but it's the entry point for all your data. Now, whether this is in a single cluster or in multiple clusters, this doesn't really matter. At this point, we have a single cluster, a compute cluster, where we're trying to ingest it and maintain the balance for your system of record. As we move the data downstream, it could push it off to a regional reservoir where it's used by the business and operations. So this is really a data mart. So you still have that central place where you have system of record. Now you're pushing it down to perhaps a data mart, a Hadoop data mart, or it could be to a SQL data mart as well. But this is really what we're focusing in here on today is more on the side of Hadoop. So we'll be able to look at the business processes, be able to add decision support capabilities. Generally, there's no ad hoc. The schema on read perspective can come up once in a while, but it's business restricted. It's really the first introduction to your SMEs. So, but it's really key is that we've sourced this data from a place that's already been made into the system of record. We're pushing it down into a place where each one of the business units will be able to control and manage their situation and track where it came from, how it's going to be used, and it's very important for governance is the permissions on it. So we like to bring the data in through something like Kerberos with authentication. Once you're authenticated, be able to map those users, those authenticated users, authorized users into roles and groups so that they have only access to the data that you decided to give them. So in data science terms, though, you could push the data off to another regional lab that's really used by data scientists. And so this tends to be kind of unsafe data. It could be inside the regional lab or the central lab. But it's it's very unstructured, right? This is where you have these wonderful people like Dan Mellinger who are going to go in there and help you understand and discover the signals. It could be have new technologies. You could use any variety of tools. It's very ad hoc in terms of how you access the data. It's really trying to get ready the data in order to look at how you want to use it, where you want to push it downstream. And with that, I think I really want to hand this over to Mr. Mellinger, and he's going to take you from here. Once we have a data we have a reservoir with the data that's curated, semi-curated, or uncurated, and he's really going to look at the data and explain to you how he would go about doing data science.
Fantastic. Thanks, Rick. And so this is a great place to start. So in data science terms, as I'm sure many of you folks on the phone know, we think about what we're doing on a data lake or a data lab as being a bit different from the way the engineering teams think about it. So all of those steps Rick took us from the swamp through the reservoir get us to a point where folks like me and my team can get in there and really start to analyze the data, and it's fantastic to get there. But sometimes we like the lab, we like the lake, we like things with a little more algae and a little less sanitation than the full reservoir goes, and that's one of the key places where we use the lake for a data lab. And the reason we do that is to be able to have unsafe data. So a lot of what we do in data science is really, we think of it as the science of data or data R&D. So how do we approach data sets folks haven't looked at before, whether it's because they're from outside of the enterprise, because they're from things we've been logging historically but not looking at. They might be things like what's often called dark data, so things like the audit data we've kept around forever but has always been stored in some silo or some tape drive that you can't actually access. And start to be able to extract insights from there. So it is, as we note, highly experimental. It typically is very ad hoc, and that's a big part of understanding the process that integrates engineering all the way through analytics and operationalization is that role that data science plays in there, analyzing that data and understanding what signal and what data sets really have, or excuse me, what data sets have signal that is viable, useful, and should be ultimately sanitized and taken into the reservoir for further analytics. So as we do that, we have some core toolkits. And in keeping with our water theme, I thought I would call out some of the tools we might be thinking of as you get engaged with a data lake. And the first thing I note right there at the top, the old battleship SAS. SAS is a great tool. It is absolutely, or I guess an aircraft carrier technically, sorry about that. It is absolutely as powerful as an aircraft carrier, but like an aircraft carrier, it's slow to turn. It's a little less nimble, and that creates a challenge for us when we look at working with SAS on the data lake, because if we're working with what we noted just a moment ago, being these highly experimental, unsafe data, a lot of it is unstructured, a lot of it needs a lot of wrangling and processing ahead of it, and because that aircraft carrier doesn't provide us with the scripting capabilities and the data wrangling and manipulation capabilities we need, we often find that we can't just work with the raw data with it. Instead, we tend to work with more smaller, nimble tools like R down there in the bottom right. And you're starting to see a growth of tools that were grown up with big data and data lakes in mind, things like H2O, Alpine, tools that have a certain amount of power behind them, but also a bit more flexibility, a bit more nimbleness. But over there on the far right, we have the submarine. And the submarine, right, just like it gets low into the water, that's how we get close and low into the nuts and bolts of the data lake, be it Hadoop or other parallelized systems. And for those, we do need, or excuse me, for data lakes, we do need to be able to get down into that level, to do some new processing we haven't thought of before, to do some data manipulation over really messy, untapped data, or maybe the data stored in the binary format. It has some sort of binary. For us at ThinkBig, that tends to be Python, and we tend to parallelize Python over MapReduce paradigms on Hadoop. But for other folks, it might be Scala or other scripting languages. But you are, as you start to get into the data lake, those key tools are going to have to include that submarine. So what I'd like to do now, as we talk about data lake and data science, is do two things. One, a little reminder on what we can do and what early success can look like. Then I'm going to tee up what I hope is an interesting exercise for the interested user, or listener, excuse me, because I do think that's helpful as you start to get into this stuff for the first time. And then we'll talk about the challenges and a little bit about who we are. So first things first, I always want to emphasize when we get into the data lake, because we see this a lot where folks have all of the data at hand, and they start asking, well, hey, how do I analyze all the data? How do I make sure all of this connected? And in reality, not all problems require all of the data, right? So statistics hasn't been invalidated by data lakes or massive scales. Sampling still matters, it still works, but it depends on the problem you're solving, the nature of the data, and then of course the sampling methodology you actually want to employ. So there are times where we fully parallelize what we're doing over a data lake, and we'll talk about that in a second. But there are lots of times where we don't need to do that, but what we do need to do is we need to parallelize our EDA, our exploratory data analysis, and our feature engineering over the lake, and then use that to connect to the tools we want. And so what this slide you're looking at now is actually an example from a customer of ours. It's sanitized, obviously, but from a customer of ours in the high-tech manufacturing space. So they connected a whole bunch of data in the data lake about all of their different sources and line manufacturing and tests that happen along the way as they're producing their high-tech devices. And we worked over that, doing some analysis of latent structure over the data, doing some feature engineering to create a representation of the signal in that data that is viable. And then we went through and actually just devised a sampling methodology over that data to capture the signal and export it to be available to what the majority of their teams of analysts really knew as far as the tool was concerned, which were SAS and MATLAB, I think, might have been Mathematica. And So that's a key part of it, right? Just because we moved into the lake doesn't mean that we have to move all our analysis there. But we do have to, at a minimum, have the right tools and features and approaches to be able to support exploratory data analysis and feature engineering, which we typically do with, again, a mix of what we just described in the previous slide, as well as things like Hive, which provide a SQL-like interface. But what I'd like to get into now is an example that I hope you folks who are starting to get involved with data lakes and data science can take with you as a take-it-home exercise, because the best way to learn this stuff is to get your hands dirty with it. So the scenario is what most folks find themselves in when they talk about getting into a data lake, right? They've got gigabytes, terabytes, maybe even petabytes of data in the data lake. It is typically a mix of structured data, maybe something like their customer relationship CRM data, things like, what your purchasing records were, what outreach we had from advertisements, that kind of good stuff, as well as some sort of unstructured data. Maybe we're talking clickstream, maybe we're talking raw text like call logs and rep notes. And it raises the question of, well, how do we leverage our data? And more importantly, how do we do it quickly? So I'm going to talk through a way of doing that. And if you are interested in starting to play with your own unsanitized data lake, certainly, you want to get that set up. There's a couple of VMs out there in the world you can try from a number of vendors. And what I might recommend is a data set. So if you're interested, there's a Kaggle competition regarding Stack Overflow classification, so classifying questions from Stack Overflow. And that actually has a pretty decent mix of structured and unstructured data. If you don't have your own data set, you can play with that. But now let's talk about, well, how are we going to go about getting a win on this data lake? So first things first, right? We all know good analytics, good data science. We've got to start off by exploring. So we're going to start off with our classic tool, going to go through, access it with Hive, doing some SQL analysis to really understand what are the data profiles in these data sets. So I just have some examples here of what we might be doing, right? We're getting averages, calculating standard deviations, correlations, histograms, all that good stuff. We can do it. We can also expose some of those summarizations to tools like Tableau. And that's another great exercise. We have those JDBC connectors. But the point is we're going through, we're doing some exploratory analysis. We get a lot of that for free from the tools that are part of a good data lake environment. And then we're going to go through and similarly maybe do some feature engineering. So as we did those summarizations, we did our exploratory data analysis, we start understanding, hey, there are these representations in the data we really want to be able to capture, whether it's capturing things like windowing, and you may find that although the newest versions of Hive do have windowing functions, that there's a need to get into our old friend, the submarine, in our case, again, at Think Big, that's Python. For you, it may be Python or something else like Scala. Or, you may be using something like a Mahout, doing some, custom Python code, which, we've done. We kind of have our own assets there to do things like clustering, really creating cross-record features, because that's a big part of what big data is. It tends to be very high dimensionality data. So cross-record features are a big part of creating summarizations and finding commonalities in data sets that have a high dimensionality representation. But so as we've gone through that, we've done some exploratory analysis, we've done some feature engineering. What might you do next? Well, I would advise, as you get to learn your data lake, don't just start off with a tool, right? You can connect, even SAS nowadays does connect to a lot of these things, but before you do that, learn to get under the hood. That's going to be our recommendation to data scientists, because the unique processing of something like a Hadoop, of a parallelized system, is important to know as you really get into the nuts and bolts of modeling. It turns out that it's really still very difficult to fully abstract that from any of those analytics tools, and so it's important to understand the nature of shared nothing parallelism, to understand how processing happens in these tools. And the best way to learn it so you can understand how you might go about tackling problems is to actually just get your hands dirty. So again, I've noted, some places you might go to or some data sets you might look at. Let's ask, what would our early wins look like where we could get a sense of how that processing works while simultaneously building statistical models. And the first one I might suggest is let's work over the structured data within that data set that you decide to look at and start off with parallelizing a random forest. So the reason I chose this, and this is another reason it's a good thing to learn as you start playing with data lakes. For those of you who are unfamiliar, random forests are highly parallelizable in what's called share-nothing parallelism, i.e. parallelism where all of the different threads running don't communicate with one another because of the fact that the forest is a collection of random trees that don't have to interact with one another, right? Just kind of falls right into that parallelism. Or that paradigm, excuse me. So what we're going to do is we can think about actually just bagging a forest, right? That's what we're talking about here, by having every single mapper create its own random forest in R. Those of you might recognize that syntax. You'll notice I'm saying the syntax there is just entry1. So all we're saying is, hey, implement a random forest that only has a single tree in each thread that's running. And the reason we do that is it's a cheap way of getting random trees, right? Trees with random parameter holdout at each node, which typifies the trees within a random forest. And I note here, right, and you guys will be able to replay this back if you want to, exactly what that process is, right? So we go from defining the number of reducer keys, setting a record to be sent with some probability, right? So that's just the bootstrapping of data, the resampling, right? Then in those reducers, which represent each sample, we actually just fit that forest of a single tree. And then we go through and we aggregate all of those trees together, right? So it's a nice, simple process, and it's an easy way to get your first exposure to building out a parallelized statistical technique over a data lake. Similarly, let's get our hands dirty. I recommend that you guys, as you try to learn this, get your hands dirty parallelizing something that allows you to analyze unstructured data. And a great thing that we do, particularly in like text classification, which is the example I'd mentioned with Stack Overflow would be, is what we do is we actually turn it into a feature extraction problem over text, and then we build models over those extracted features. So feature extraction over text can be done a number of ways. One of the more straightforward and easy to parallelize is information gain. And so again, we call it exactly how we do this. The key thing is to understand how information gain is calculated. If you're unfamiliar with it, it's a good thing to go look up and learn. But information gain, insofar as it's built on conditional probabilities, is really a question of counting. And so for those of you who've had exposure to Hadoop before, you'll remember the classic Hadoop use case is counting words. So calculating information gain is very simple, again, in a parallelized setting. So we can go through, get the information gain for individual words. If you really wanted to, you could try to make them n-grams, so that's a little goofy. And then what we've done is by selecting, say, for instance, the top 500 words based off information gain, which actually is a common way of doing feature extraction for classification into things like a forest, which is what we're about to do. We can go through, select the words that have the highest information gain, i.e. those that best discriminate between the different things we're classifying. And then we can go through and take those results and just repeat step 4 again. Create a classifier that's parallelized over those features. And so if we go through that, we can ensemble those two models, or you can actually just extract the features from text and just bring them into the same model as your structured data. You can decide which makes most sense based off of what you're doing and the nature of your data and the problem. And once you do that, you have gone through your first lesson of working off a data lake completely under the hood in a way that will allow you to really start to appreciate what data lakes are good for and what they aren't good for. So I highly recommend that as a first exercise. So before we wrap up today and get into questions and answers, I'd like to cover a few things. One of them is what the key challenges of a data lake are. So this is one of my favorite slides, right? Really typifies what we see as the key challenges. So you have business up there, fishing. You've got IT in the water is represented by the yellow submarine, and we've got some data sets represented by fish. And the first thing we really see as being a challenge for a number of our customers out there in the space is when they can try to continue what I'll call the throw it over the wall relationship or customer service relationship between IT and business, right? That's been an old model going back a number of years because of things like RDBMS data and the notion that, hey, business will come to IT, ask for a certain data set loaded or a certain service enabled, some new cube stood up, and then they'll go through and they'll analyze data. But in the world of big data, as Rick noted, the iteration patterns to getting to a sanitized reservoir are complex. And they typically require, again, as I noted earlier, a little bit of data science to understand, well, what are the new data sets that have signal we care about? What are the things we want to bring into a sanitized reservoir? What are the things that don't belong there? And so it requires, over and over again, a partnership model between business and IT. So you can both be up there on the shore fishing, or you can both be in the water in your submarine, your favorite other metaphor. But we really recommend that when you get into this path, our customers break out of the customer service model between business and IT and into a partnership. The next challenge we see folks falling into is really struggling to understand what are big data use cases, right? So big data solves a lot of interesting problems, but it also can just be a mass of data around problems we've already solved. And being able to delineate between those two is very important. So we have cases where adding new data is just noise. We have cases where adding new data just adds complexity to the process but doesn't actually add new signal. And then we have big data use cases where new signal or new opportunities arise, right? So the difference between saying, hey, we're just going to add more and more customer interactions representing the same thing where there's only 5 choices, which is a relatively low signal setting, versus continuing to add new channels of interaction, right? Continuing to integrate from the traditional CRM, past clickstream, past phone logs, through mobile, all of that good stuff, right? Those are all unique sources of new insight that are truly big data. So the question is, when do you have to go to the lake and when do you not? And that's a key thing that folks struggle with. That's why we have, the fishermen fishing for fish sticks there, right? When you need a fish, you go to the lake. When you need a fish stick, you go to the freezer. So very important that as we go through this process, we don't necessarily advise folks to transition everything on the data lake, but to instead address the problems that are truly big data problems, where are truly big data use cases, and go fishing for those. The last thing I'll note here is you have all the fish kind of swimming in different directions here on our picture. We've got our CRM data, we've got call log data, we've got clickstream data, right? Kind of classic examples of multi-channel. But all the fish are swimming in different directions. Our fish aren't swimming in a school. And that's a big, big technical challenge when it comes to implementing the data lake. And part of it is everything Rick was calling out in terms of, the processes of getting the data ingested, getting it cleaned, all of that. But it also is a data science challenge in many cases. What we find a number of times is that when our customers start trying to join disparate data sets in the organization, there aren't common keys. And even if there aren't common database keys in that truest sense of the word, there aren't even common other fields or other pieces of data that could consistently be used by a key. Sometimes you can join off an email. Sometimes you have to kind of look at the address, but the addresses are formatted in different ways, et cetera, et cetera, et cetera. And in fact, what we find is that joining all of that different data is often a data science problem around fuzzy matching in and of itself. So to get our fish to swim in a school is a key challenge, and it's often a place where we have to integrate data science and engineering. So with that, I'd like to just wrap up, get to questions, but last thing before that, I want to talk a little bit about who we are and what kind of folks we hire, what we do at ThinkBig. So I'm going to briefly turn it back to Rick to talk about who our data engineers are and what we value, and then I'll talk a little bit about the same around data science.
Great. Okay. Unfortunately, I've lost my connection here. So, let's take a look.
You're up where who we're hiring, engineering. Can you see that slide there, Rick?
So, yeah, I got it. So, anyway, so today, as far as data engineering goes, we are hiring really passionate people with great engineering skills. They have fundamentally great programming skills, system integration skills, and really we have a real big emphasis on repeatability and consistency in how we build things. So we're looking for people that have that discipline to be able to work with us, and lots of great Java experience as well. We tried hard to make sure that the foundation is there for all the people that we bring into our team. Yes, next slide would be about data science, right?
Indeed,
yes,
thank you, Rick.
Yep.
So in terms of who we hire from data science, we continue our vehicle analogy, right? We've had a lot of water metaphors today. Now we're going to have vehicles. But the key thing that we really focus on are people who can drive analytics, right? We believe that, the engine's really important, the tools, the machine learning, the techniques and approaches, but, the platforms, the wheels, also critical, but the car doesn't go anywhere without a driver. And the driver, for us, is the person who really has the domain experience, the analytics chops, and the passion to take what is just data. At the end of the day, it's just data, it's just statistical techniques and algorithms, and translate those into something that truly represents, explains, and predicts the realities of our world. And so we are not believers that you can just throw an engine at that problem. We believe it takes, people who are really passionate and curious and knowledgeable about statistics to make that come to life in a meaningful way. So we'll just wrap up. Please go ahead, Rick.
Yeah, so if it's done right, a governed data lake becomes a social reservoir. And I saw some questions on governance and where that comes into play. And that's really where we're talking about being able to authenticate and identify and make sure your data is securely transported and pushed into the lake, as well as mapped to users' roles and responsibilities. So governed data lake is essential. You need to leverage those proven patterns and best practices that we talked about. In data science, over lakes creates unbelievable opportunities and challenges. So we like to think big to start small. We think big, but we start small and we iterate. With that, I think we're at the end.
Okay, we'll jump to our Q&A portion of our event today. So thank you, Rick and Dan. Great presentation, very thoughtfully laid out, and loved all the metaphors. So folks, we're at the Q&A portion, as I just mentioned. I'm going to put the slide up right now that you should all see. It includes the contact information for both Dan and Rick. If you want to jot it down and contact them following today's webinar, feel free to do so. So with that, the first question is, where does data governance fit in with data lakes? I'll let you both field that question.
Yeah, so I think I tried to address that in my kind of closing remarks. That was basically where, you need to know where the data came from. So what we do is kind of understand any pre-processing or packaging up before it lands in the lake, push it through a Kerberized authenticated pipe, land the data. When the data lands, the person who landed it, authorized it, is authenticated. And with it, we also package and co-locate the metadata, the operational, the schema, the security, all that stuff comes together when we package it and push it through that Kerberized pipe and land it on Hadoop. So once it's landed, then we now can map the data to the users and the profiles that are on the lake, so that only people that have right accesses will be able to use it. Hope I answered that question.
Okay, very good. Thank you for that, Rick. Dan, this question is for you. Are you advocating that all SAS programmers need to learn R and MapReduce?
Certainly not. We're not advocating a single tool of choice or a single skill profile for the organization. I certainly will note that when we walk into enterprise clients, right, they typically have a lot of existing skills in tools like SAS, as well as, to a lesser extent, R and Python. And typically what we like to do is we like to get in under the hood of those use cases, understand not just what use cases require which skills and align those in a blanket sort of way, but typically what we find is that as you transition into big data use cases, there are certain what we'll call foundational use cases that support multiple objectives, multiple outcomes that require certain core skills. So for instance, when we worked with a financial services customer of ours, we engaged with them as they were going through some deep analysis around multi-channel data as it pertained to propensity to engage in certain services they offered. And well, they had a great deal of SAS skills within-house. There was a need to do some analysis and feature engineering and feature selection over Hadoop with R and Python, kind of that classic toolkit we work with. And so what we did is we said, okay, let's see how much of the feature engineering, feature extraction that was a mix of unsupervised and supervised analysis can be done by a small group of folks who support and enable that data to then come out and be accessible to the wider audience of folks who have more traditional analytic skills. And that's a critical way, we looked for our customers and for our own teams to use data science to enable advanced analytics at scale over big data.
Okay, excellent. Thanks for that question. Great answer. The next question is metadata stored within your data, or is it stored in a separate file?
Great question. So what we do is we actually build out the metadata and package it up along with the way we want to efficiently ingest the data itself. So solve the small file problem and the large file problem, but also co-locate and store the metadata with it and all the different aspects that I talk about it. So when we ingest and we land the data through that governed pipe, as we talked about before, we land both the data and the metadata together in the same file. From there, we're able to track everything that came from and inside. We also will push that metadata, once it's landed, into a visualization metadata repository management tool so that you can visualize it and understand it more. So good question. We do definitely recommend bringing both the data and metadata together, co-locating it so that everything is correlated.
Great. Thank you, Rick. Next question is, what's the advice in bringing data scientists closer to operational implementation of models? We've seen issues of data scientists struggling with the reality of their implementation going straight into production / commercial environments. Can you guys respond?
Sure, and certainly I think it depends a little bit on what you mean by, I'm just looking at that question now, struggling with the reality of their implementations. But it's certainly something we see quite a bit as well, and I think there are a number of challenges there that can be called out. So one of the first ones we see is that often data scientists end up getting buried under IT or somewhere else in the organization, and they're so far from how people actually use the data, right? When we talk, at least when I talk about operationalization, we don't mean in the sense of just going into production. We mean operationalizing at the organizational level, being integrated. Whatever you're doing, whatever you produce, being integrated into the existing business processes of the organization. So if we create a model, but that model doesn't actually impact the way people make decisions, it's not real, right? And that's a critical thing, but if you have folks who are completely separated from business, they can't do that. So certainly we advise as people build out these data science analytics organizations, right, there's a little bit of overlap in language there, they invest in a hub and spoke model. So, thinking about how you can have a small center of excellence that supports the core needs and helps identify repeatability and advocacy within the organization, but ultimately you build the large hubs within business. Certainly also, you see some especially short term, but I think long term it's still just organizationally a very healthy thing, although it is costly, things like a need for role rotation in that regard. But finally, I think part of it is cultural, right? So if I'm reading your question, I think the other thing I'm reading in there is that there's a challenge around, folks going from just the R&D into really being able to think about how their model comes to life in an engineering session. And that is not just a question about data science, that's a question about engineering. And that's why it's so critical to have those two worlds married up to each other and have a culture where those two groups can work closely with one another.
Thank you, Dan. It's a very thoughtful response. The next question is, can you run a data lake of any kind, can you run a data lake on any kind of platform like Hadoop, Spark, or HBase?
Absolutely. Matter of fact, BigBig does deploy on all of those platforms. We tend to use HBase more for derived values. It's because it applies a structure. So if you remember the kind of the curated, non-curated perspective, HBase is closer to the curated part, just based on this kind of structure and format. But we definitely have built on both Spark and HDFS Hadoop-based lakes.
Okay, very good. Next question, and since you mentioned curated, this is a perfect segue. Is metadata structured, and is it curated before going into the lake?
Well, metadata by very nature is helping you to curate the data, right? Understand the structure that it's in, and also the structure you want it to be in. Okay, so you have the base schema and the target format, and so basically we worry about both aspects of it. The metadata. I think, did I answer that question?
Yeah, I believe so. Dan, do you want to respond to that? Or are you okay with the answer Rick just gave?
No, I think that's spot on.
Okay, great. Quick question from the audience was, do you offer internships? And I just put up the slide because everybody should be aware that Think Big is hiring. So their information is there, but perfect question for the slide that is there now.
Yeah, and I'll just note that, and thank you for putting that slide up. So, we're hiring engineers, data scientists, sales, project managers. We're growing very quickly. We're going to, double and probably double again the size of the company over the next couple of years. So it's very exciting for us, and it's part of, what's been great about operating as an independent brand, but still under Teradata. And certainly we are looking for interns as well. It's part of both how we invest in the community as well as our own growth. So please do reach out.
Okay, very good. In line with that, here's a question from our audience. That I am a data science student graduating from an analytics program at my university. How do I get started with a data science career?
Oh, I think that's a fantastic one. So, obviously, there's a certain amount of skill gap that you may or may not need to cover. And it depends a little bit. I think sometimes what we see is folks who come out of analytics programs at universities have some great kind of core analytics and statistical skills, but they might be a little bit weak on the skills needed to do data wrangling. So if you haven't yet learned a scripting language like a Python or started getting your hands dirty with really coding R in a repeatable, usable way, definitely help yourself by doing that. But again, never forget that although we talk a lot about tools and technologies, ultimately, right, successful analytics relies entirely on domain expertise, right? If you don't understand what it is you're modeling, if you don't understand how what you model comes to life and impacts the organization, you're not going to be able to be an effective change agent within that organization as a member of the analytics team. So make sure that as you go through your career, you're doing everything you can to not stay kind of under your bubble, but really walk around the organization and learn how what you do impacts others and how others consume the things you produce, because that's the key to a long and healthy career in this industry.
Very good. Thank you, Dan. The next question is, since we're on this topic of hiring, are there data science boot camps where I can tune my skills?
Yes, there are a number of them out there, and I apologize for not recalling the names of all of them. In fact, I may try to pull some up as we chat, but there are a couple that are tailored just to folks coming out of PhD programs as well as folks who are coming out of any kind of background, although those tend to have to be a little bit longer, but I think they're fantastic. I will try to dig those up. Maybe we can post those or feel free to reach out to me directly. The other thing I'll note is there are a lot of great courses out there now. One of the ones I had recommended to some folks internally who were looking to transition from engineering to data science was a Coursera course called like the Data Science Certification, and it was sponsored by Johns Hopkins University. And the reason I really liked it, and I would just say anything you look at, make sure it has this, which is a good data science program or course or whatever you're going to call it is not just going to be about algorithms. It's also going to be about the nuts and bolts of statistics. It's going to be about hypothesis testing, research methodologies. All of those things are critical to doing this stuff effectively and not just being someone who pushes a button and hopes the computer's right. So please make sure when you look into things that you're seeing that side of development as well.
Great. Thank you for that, Dan. That's going to be it's going to have to be the last question since we are pretty much out of time. So for those of you that did ask questions, rest assured everything is being sent to Rick and Dan and Think Big, and they will be getting back to you directly. Just have a quick couple announcements to make. Please mark your calendars for next Tuesday, March 31st, in our next Data Science Central webinar. Learn how to work with large data sets to build predictive models with Microsoft's analytics tool, sponsored by Microsoft. This brings our webinar to a close. I want to thank Think Big for their sponsorship of today's webinar, and a special thank you to both Dan and Rick for their insight into today's topic. My name is Tim Addison. It's been a pleasure to be your host for today's event, and I look forward to seeing you all again next week. Good day.